LDLC, the SDLC is a process framework which specifies the tasks to be performed at each stage in the software development cycle. It provides that kind of step-by-step, which must be followed because we are saying that the software development life cycle is a structure or is structured with clear guidelines on how softwares are developed. Now, to go further to explain this cycle, first of all, we need to define all the non-functional and the functional. I will explain them as we go by. It's developed on time, delivered on time, and it's within the budget that we agreed to do. Then it's actually achieved all the characteristics as we mentioned in our previous meeting in terms of also the good attributes of the software. Then we can actually get it deployed and maintain, and also ability to scale or ability to update throughout its lifetime. Okay? Now, it matters because software engineering matters because people are just, eager to get contracts, but then once they get a contract, because they are not guided by this life cycle, they find it very difficult to manage. For example, this school management, someone came and said, oh, we want to develop school management. And he started just like that, forgetting that the school has 3 different schools. We have the regular undergraduate, the regular postgraduate, the distance learning regular, and the distance learning postgraduate. Now imagine the person came and only focused only on the regular student, forgetting that the postgraduate also has its own, the distance learning also has its own procedure. You realize that now there may be a lot of code changes and it will affect the cost and the entire development of the system. Now, this group called the Standish Group Chaos Reports, okay, the Standish Group actually had this called Chaos Reports. Okay. Now, this chaos report refers to what? The high persistent failure and inefficiencies rate in software development, which primarily is caused by poor requirements, lack of user involvement, and unrealistic expectation. Okay, so let me put this information here. Okay, first to the high persistent failure and inefficiency rates in software development, often caused by poor requirements, lack of user involvement, and unrealistic expectations. Yeah. So basically, that's what the standard chaos report is about. So they did a research and they realized that there's high persistent failure, and inefficiencies, which they saw that mostly was caused by these three main problems. Poor requirements. So poor requirements, as you all know, we have two types. We have the functional and the non-functional. So the functional requirements are basically what it is needed from the customer, how the system or how the application should look like. For example, so we are building the school management system and you are focusing on the ICD. Now, the ICD, how do they run the school? The operations of the IC, how do they run? So, for example, the ICD, you may need to register because you are not likely to be coming to campus often. So, which means that the operation on the ground should be translated in the application. So, the users or the customer should be highly involved in the requirements. So, we have the lack of and unrealistic because maybe that company may have developed one before, so they thought it's going to be the same way, so they have unrealistic, they set unrealistic, within 2 months we're able to finish, forgetting that a whole lot is involved, from the applicant applying, how the students are being their results are being processed to give them the required program to pursue. And the person need to pay, and the course registration, and when the students are about to graduate, what are the processes? And even the financial management should be highly be maintained. So if the previous software that they won the contract and they develop, some of these things are not involved, and they thought it's going to be the same, they may set expectation that in the long run, they will come to realize that they are unrealistic. So they came out to say that per their report, there are some they're consistently they find out that 30% of software projects are cancelled because even they don't have even expertise, they don't have maybe the financial strength, and often half of what the percentage actually at the end of the day, the budget that they actually was set for themselves, they will exceed it by 50%. And only a marginal succeed with the original constraints. So constraints basically hurdles. The obstacles that they meet on the line. Maybe some are unforeseen or some they are expected to meet. Okay, so which means that the constraint basically what you agreed on based on the budget limits, the workforce, everything. Only 20% are able to succeed, which is actually really, 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 really concerning, because out of 100%, and we only 20% are able to succeed, then software development cycle really matters. So in this cycle directly addresses this failure by providing a clear map so that all members, all engineers in this class understand what to build and how to build it. Establishing checkpoints or milestones and review gates. So which means that we need to have testers, overviewers, reviewers that will be managing that will be reviewing the application at each milestone before the problem actually escalates or actually increases exponentially. Now, also by reducing real work caused by surfacing defects as early as possible. Now, real work is basically you work on an idea or in a task, and for some reason there was a change and you may need to rework. So which means that the cost to actually rework, or you actually work on something and those code actually got deleted. Now you need to rework. What is the cost? Perhaps maybe the person who reconnects actually is left, no documentation because there was no clear roadmap involving stakeholder communication through consistent documentation and reporting. At each checkpoint, there should be a thorough communication between your company and the customer, which means that you as a class and the school as a customer, through consistent documentation and reporting. And it should be very, very clear for both parties to understand and look at the way forward. When people realize that software development lifecycle is very, very important, it enables you and I as a company to actually better resource our personnel, being it money, being it computers, being it all that it takes to build the system, and the risk management. Is it that we allow the engineer to work from the house? Or will we brief about if there's a breach, what should happen, how users or how the engineer should manage the data so that the data will not be in the hands of unauthorized user or users, and how best we can track the project. So which means that we may need to have another software to which we can track the project. And we have so many softwares that is out there, or the company can build its own customized one. Then increasing the product quality, the reliability, the maintainability over the long term. So software engineering is one of those few courses that once you master it, there's not going to be deviation when you get a job in this field. Now, all we are saying is that this software development lifecycle is just a blueprint to which all software engineers should follow when developing a software. So it is seen as a conceptual framework. Now, people have developed different models that uses this cycle. So you have the waterfall, the agile, and the spiral. The other models, more than what you see, I will show them, and they have a different approach. However, maintaining the core principles of this life cycle. For example, every car should have a fuel, and the fuel should such that the fuel should be more environment friendly. It should not actually consume, or the car shouldn't consume so much fuel. Now, companies have devised several ways of ensuring that. Some uses the petrol, some uses the diesel, some uses battery, what we have the EV. But then the core principle to make sure that users should have maximization of what? The power that those fuel actually generates. So you could see that every car have a different way to which they use in their car. But then the accelerator paddle moves the car, reverses the car, park the car. But then they use different models to achieve the core principles of how car should actually navigate from one point to another. So basically that is that. Now these are the models. They are about there are many, many more, but then we are looking at the one which is most popular. So we have the waterfall model, So I'll not go into details. I'll just explain what is best suited for, because you're looking at them one by one later. So with this one, okay, I'll go to the core mechanism because it's very, very important. Yeah, let me chip in there. So the waterfall model is broken into phases. So you have phase 1, phase 2, phase 3. And in order for one to move from phase 1 to phase 2, the phase 1 should be what? Entirely completed and closed before the phase 2 actually what comes. So which means that you can't go back. And if you go back, you need to start from the beginning, because the phases are connected to each other. So they are used for complex systems or bigger applications. Now you also have the agile, and this is actually what most of the engineers use. And this one requires what you call, and let me also want this one, everything. So which means that we need to take all the requirements, everything from the user, so that we build everything without the user involvement, because we have all the requirements. So which means that they should what? Have a well-defined requirement. But with this one, it's basically where we have what you call sprints. Sprint cycle, excuse me. Sprint cycle, which often takes 2 to 4 weeks. And that one actually involve the stakeholder, which is the customer, which means that any little that you do, you engage the customer moving forward, which means that you may not require all the requirements from the head go. No. No. So which means that with the sprint cycle, let me explain what the sprint cycle means. So the sprint cycle, which means that we set a target, not an entire target. For example, in our school management, the first major task is to handle the admission system. So the admission, we take a sub-model, which means that, for example, what information do we need to ask from the users? So let me show you one of them. So I'll show you one of them. So I will show one from our school. So our school is apply.gctu.edu.gh. Yeah. So for example, how to apply. So it's basically, we call them sprints. Okay. So how to apply, then we look all into the models on how to what? Apply. And you realize that in our how to apply, we have where you need to what? Go and purchase the cereal and the pin, or use the voucher from the mobile money, or using the or actually this. So we're going to look all of this. Then we can break that into smaller tasks. So maybe we concentrate on this one, then we come to this one, then we come to this one. Then with this small distance, we're going to look at what you call the estimate effort. How much time, how much resources do we need to what? Build this? Then we define the goal. So we do all of this. Now, so this is actually how, so with this, you realize I need to buy the pin before. But let me show you in other jurisdiction how that really works. Now let us now go here. So basically, I want to show you this because this is where I studied. Okay. So yeah. So for example, undergraduate. So so you could see that with this system, with this approach, you select the available program to see what is there first before you apply. But here, it has a different ballgame. You need to what? Pay. Whether the program that you want to apply, it is there, it is not there, you need to what? Follow this. So all of these things eat into the sprint. What do you want to build? This side, and how do you approach it? And this approach basically may come from the customer, which is the school. But in other schools, it's not like that. For example, you need to, I prefer this because it's very easy for you to know what the school is running first. So I choose computer science. Now, this is the entry that they have.
Hello, sir.
Yeah?
Please, are you showing a different screen on the slide?
Yeah, the slides. Or I'm showing something different.
No, I'm
Okay,
seeing the slide.
okay, sorry.
Thank you.
Yeah, so this is what I was showing. The agile. So the agile is 2 sprints. So in our, so the sprint, let me explain this. So the sprint is basically 2 to 4 weeks. Okay. So within that period, we take a model. So the model is what? The admission system. And under the admission system, the first sub-model is basically how to apply. So how to apply, we break them down. So here, if you look at the GCTU brand, you need to pay. You need to buy what you call the voucher before you can what? Apply. But in other schools, you need to see what they have before you apply. And all of these things come from what? The customer. But then the software developer or the software engineer may come in to give them the pros and cons on the approach that you choose. Because unlike the approach that you need to see what they have before you buy. Because in terms of the fees, everything. So look at this one. You choose the course here, then the date, the start date. So there, you choose whether, let's say, full-time, part-time, distance learning. The moment you choose, it shows you where your campus will be, the entry requirement. But here, you don't have the entry requirement. So which means that you may buy the form and later you realize that you don't qualify. So here, you need to look at the, okay, the qualifications so that once you are assured, you are assured, then you may also need to look at the fees. Do you have the money that they are stating? Not that you apply and later you don't have money. And the payment plan, everything is there. So it gives you the user that you are pre-informed, not that you apply, then you will be stuck along the way. Then you can apply now. Okay? Then you can apply now. So you apply, then you may need to what? Sign in. And this one has the same feature with KNUST. I've actually put in a proposal to management to actually relook at some of these things. So, if you come here, you like to go and purchase the voucher. But before you purchase the voucher, you need to register. Once you register, then you will actually look at the fees and every component. You select the courses. If basically that's what you want, then you go on to pay. That's all. So this one also applies to what? The agile. The waterfall. Everything must be there. So you see, heavy upfront documentation, but this one is adaptive. As and when we have the requirement, then we also set up to build it, and requires continuous stakeholder feedback. Because everything that we do, we need to make the user be aware, engage them every day. Likewise, we have the Scrum, the Kanban, the Spiral, the V model. We'll go into details as you go by, the RAT and the prototype. Now, choosing the right model. Now we are being confronted with the GCTU model. GCTU. They are actually we found a contract. Now they say they want to develop build school management system. They've given us the modules. Maybe we need pre-admission, we need student model, staff model, finance model, library model, learning, the LMS model. Everything is there. Now, as a project team, which model do you choose? It's not that easy. So this table gives us a guide. So first of all, you need to know the requirement clarity. Do we have all this upfront or as and when we need? So where everything is intact, not that you go and come back, the waterfall or the view model is highly favored. However, if the requirements are vague, evolving, or the requirement keeps on changing, then the agile, the scrum, or the spiral, because they are using the iterative model. So the iterative is like, you may need to go back where necessary, but sequential means once you finish the first stage, you are not going back again. You are continuing to the next stage. Basically, that's what it means. Customer involvement. This one is only at the beginning when the customer has every document, and the end when we are actually what? Showing them the final product. And this one is throughout the cycle we need it. The project size and complexity. If the project is very, very small, waterfall is required. But where it is large and complex, like the school management, we are using the what? The agile, the scrum, or the spiral. Or we can actually combine all of them. We can actually combine, just like a car may have hybrid, either diesel or petrol, or diesel or EV, or any of what, or diesel or hydrogen. We shouldn't have any problem using that. Any question up to this point, ladies and gentlemen? Now let's move on. Now, regulatory involvement, where we look at some standards. I mean, in terms of the build standards, is very, very essential in all of them. Okay. Then the risk profile, since it's a medium to small, it is very well low, whilst the other one is just the opposite. The team size, okay, so this one may require very large number, and this one may also require large, but then they may scatter, or I mean, we don't have really a problem with that. And the delivery is going to be there because you know the scope from day one. But with this one, it's actually what depends. Okay, it's actually what depends. So now the software development life cycle comes in what phases? They are actually what 7 stages or phases when you are using this life cycle, independent of the model that you are choosing. But some models may combine multiple phases as one. Okay, but then since they all have the phases printed in it, that will be no problem. There won't be any problem. Now, each phase has its goals that will help us serve as a catalyst to the next stage. So it's very, very important that we understand the purposes, the activities, the deliverable, the roles, and some common failures that each phase has for us to know and appreciate. So the first stage is basically the planning. So now the question is, should we build it? For example, if a company is advertising, looking at what information that the customer has presented, the question is, do we build it? So which means that, first of all, we need to have the feasibility. So we go to details, what the feasibility and the project charter, which will give us the report as to whether we can or we cannot. Requirement analysis. What should the system do? And with this, it will spelled by the customer, either vague or not vague. So now we have a report that we need to write on what the customer expects. Then we look at the system design. How do we build it? Okay, so which means that we have the architectural document, just like the building plan, that contains the high level to medium level to the low level. Just like a building, we have the entire plan. Then on each room, we go deeper to know the measurements and all of that. So the school management system will have all the plan design from the time that the student or the applicant apply to the time the student becomes an alumni. All of this should be what? Designed. And how do we build it? Are we using stones, blocks? Are we using bricks? What are we using from the ground zero to what? 100. So the languages is involved, the database is involved. Maybe you may use cache server, you may use distributed server. All of this, the operating system that the application will sit on, is it something that will be hosted in the cloud or the customer premises? Now, the implementation. How do you write the code? We have different architectural designs. So we have the solid principle, we have the clean architecture. We have different types. And how do we test them? And also, even the development, how do we deploy the source code? The testing integration, we have an comprehensive report on all the various units that we've developed. We test, we write a report, and where there are issues, we also need to integrate, we also need to list them. Then we have the sign-off. Deployment, how do we deploy it? Then maintenance, how do we keep the application running, and how it will adapt to what future requirements. So these are basically the 7 phases that any model which is implementing the software development lifecycle should undergo. Now let's come to the phases. Oh, sorry, the phase 1 or the first step, which is the planning. So this one serves as what the stepping stone. This one serves as the spinal cord to which will be what? Building the project. And normally the reason for which this software need to be built mostly rests on the customer. So the customer will now raise what you call the business case, why they need it. So a question to you guys. Now you're going to play the role as a customer and the software engineer at some point. Now, I'll also hand you a book. Let me see here. You know what's software, fifth edition. Fifth edition. No. Let me check online. So we have fifth UML system analysis and design. I think we may be in the 7th edition or so. So there's a book that I would like to let me check. There's a book that I gave it to one person that I was working with. Ah, there was this document that I had. Oh, no. Let me look at the 5th edition. Let me see if this is the book. Not this one. There was this book that I normally use. Let me see. I think it's this one. Not this one. Not this one. Not this one. But much similar. Oh, let me see. I used to have this book. No. I'll look for it and share with you. This one. So I will share with you, then and this one goes into details how you can formulate the business case that the customer writes. Okay. So and it should be properly written. So it's defined the scope as well. What should be developed and what should not be developed. Then it should assess the feasibility. So the feasibility means, is it something that we can or we cannot? And also align or allocate resources to it. So a project team without a planning will suffer from leakage of, a bar scope, budget overrun, which means that the budget may not go to, or they will not have any alignment with the project, then the deadline will definitely be missed, and misaligned stakeholder expectation. Yeah, so this is the book. So let me show you here. Yeah, so which one? So this one, you come in basically as what? A system analysis. Okay, so I'll give you the book. Let me download and share with you guys. So that let me share in this in the chat so that everyone can have. Where is this thing? But this one, where is it? It's on the downloads. Oh, resume internet connection. Okay. So nevertheless, I will share the link. It seems that I'm not able to download. I'll share the link with you guys. Then you look at it. So to guide you on how you can design certain aspect of it. Okay. So this planner would basically answer the basic question: should we build this and can we? So which means that in this planning, we require the business case, the scope, and the feasibility. So at the end of the day, your assignment is to build a comprehensive plan for the school management system for GCTU. So the key activities is to define the business, the scope, the document, what is especially what included and what excluded. So you are going to look at yourself as what the customer and at the same time the software engineer. Then you develop the business case, you conduct a feasibility study, which I will show you below, identify all the stakeholders, which means that basically from the customer side and internally, the estimate cost, the duration, the resources that you involve, then identify the project risk. Okay, you actually, so these are the stakeholder are the customers. Then you define the project team structure, who and who are the roles. You define the model and the development methodology. Okay, then you establish the communication plan. How do you guys meet? Do you have a channel that you guys meet? How many times do you meet within a certain period? And the channel for reporting. Then you define the quality metrics and the key performance index. So when you come down here, okay, so you could see that the initial planning is here, okay, and so you're going to look at the part one, which is the project planning. So the project plan, as you could see, identify the project, you develop the system request, which is going to details, then you provide all the feasibility. All of this you guys need to do. So this is actually a book that will guide you to develop all of them. Okay, let me try to get, if I'll get the book. No. Surprise. No, this one. Oh, I used to have this book. I'm surprised. I used to have this book. All of a sudden, I can't find it. I don't have it. Unfortunately, I'm not able to download. I'm sure it's because of the network also. Yeah, because it's coming from the site is not a secure site, so it's not allowing me. Let me try to get to the title. Let me try and get the title and see if I can download for you guys. Yeah, so I think this is the fourth edition. No, 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 no. Even it's not even a secure site. Okay, so I have Google. So oh, I'm not getting this book. Let me try and get it so that oh, okay. I think even this CTO has it. Okay. Oh, how come? Oh, why am I finding it very difficult to? So I think this one I can download because yeah, so I've able to download the book. So I will share to you guys. And I also actually keep one copy for myself. Yeah, so this is where you'll be referencing for all the assignments that I will give to you guys. Okay. So the feasibility studies, we have the technical. So the feasibility study, we have the 5 dimension, but the book has I think only 3. So which means that you need to add the remaining 2. So it says that the technical, it's can we build the system with the available skills, technology, and infrastructure? Yes, because all of you is assumed to have all the skills and the technology. Then you produce your assessment. So this one will be used internally. Then the business people will actually siphon some information out of it and they will use it to bid for the contract and they will be guided by the document throughout the development. Now, economic. Does the expected ROI justify the total cost of the development of expression of the cost and of development and operation? So the ROI means return of investment, which means that we'll be able to have some profits at the end of the day. Okay, so you are looking at the profit margin. Okay, so this is where the business aspect will come, but then that one is up to the top hierarchy. But you're looking at the core, the operational. You also have the legal, the schedule. So all of this, you should be able to know and plan towards it. Okay, so now, in order to estimate the cost techniques, okay, so it is very, very important that we need that in our project management skills. Okay, so which means that we may need to have some key methods that we may use to estimate the project. So we have the expert management. So that one, we rely on the expertise of the senior engineers and the domain experts in our company. Or we have the top-down approach, where we may use data from similar projects that we have done as our baseline, so that we try to cut down some other processes. They also have parametric estimation, where we may use some models, mathematical models, to do that. They also have the top-down, the bottom-up. You also have the 3-point estimation. Just to let you know. They also have the agile, where we may use this consensus to counteract occurring bias. So we may use some of these things to do. So at the end of the day, we will be using this charter, which formally provide all the information that we need, and the project manager will actually present it for management to decide, which will contain the feasibility report, the project plan, the risk register, and the stakeholder register, and the communication plan, and all of that. Okay? So the two most general planning failure, which is the scope creep, which means that if you don't have a proper or a strict scope, some scope may be creeped into while in the initial plan it wasn't there. Or the developers may be adding some feature that the customers have not even thought of. Okay, so it's very, very important that we know all of these. Okay, so today I will not go further from here. I need to do something very quick, and I would like to end here, so that you try to digest all that we have discussed. So I want to know from your class, what's the total number? Is the class up here? What's the total class number? Class, can you answer me, please? What's the total class number?
Please, 14.
Okay, 14. Do you have groups yet?
No, please.
Okay, so if you don't have group, let me share the group right now. So Stephen Amwa and Desmond Tete. You are in one group. Stephen Amwa and
Please use Stephen Asamoah.
Asamoah, sorry. Stephen Asamoah and Desmond Tete.
All right, sir.
Okay, as one group. Collins
Stephen Amwa.
and George. We have Noble and Emmanuel. Emmanuel Azache. We have Nyako and Prince. So Nyako and Prince. Then we have Seram and Steven. Steven, is it the same Steven as someone? Okay, no, then let me skip. So it's going to be Seram and Winner. Yeah. So we have Stephen Asamoah and Desmond Tete. We have Collins and George, Noble and Ima, then Nyako and Prince, and Seram, and the person is called Winner. So if you are here, this is actually your first assignment. So the assignment, as I already told you, we are to build a school management system for GCTU. So yours is to provide the project charter, okay, which contain the feasibility report, the project plan, the risk register, and the stakeholder register, and the communication plan. So you have this book. I've shared a book here that will guide you. So whatever you don't understand, kindly draw my attention. So this one, it goes into details to provide what you call the system request. It's basically like the charter, okay? So, or the identification of what the project. So if you are here, no, I think that one is chapter 2. But it has some traces for the chapter 1 as well, okay? Just something very simple so that we can actually match it from there. Then we go to the next stage. So if you could see that even the chapter 1, everything is there, the project estimation, everything is there. So you are going to look at some of it. So the ROI, which I mentioned, is here, return of investment, everything is here. So can you go through, and I need this assignment. I just need something that you yourself can show that indeed I was able to do something like this. Okay. So I will end the class here. And so you could see how the feasibility report looks like. So this is the project summary. So you follow these guidelines. So it provides the technical feasibility, the economic feasibility, all of that, and all of that. You understand? So all these are spelled out in this book so that all of us will basically what follow. Oh, I think this book is no, I think this book doesn't contain all. It contains only up to page 66. So which means that you may need to fall on the link that I shared here. Let me see the link that I shared, if it contains all of them. But the name of the book is, let me share the name of the book. So if you can also have a way to download it, then you download and share with all of us. So this one is up to the last, which is what, 594 pages. Okay, so you kindly go through all of this and let me know. Okay, so I wish you guys the best of the day, and stay safe. Okay, bye bye. So I'll be leaving then. Yeah, bye.